Hi, my name is Eric Johnson, and I'm a Senior Developer Advocate for Serverless. And today, we're going to be talking about mastering AWS SAM, the AWS Serverless Application Model. Now, let me tell you a little bit about who I am. Again, my name is Eric Johnson. You can find me on EDJ Geek on Twitter. I'm a Senior Developer Advocate for Serverless. I've been here for about 2 years. I'm a serverless tooling and automation geek. I've been a software architect or solutions architect for the last 25 years. I'm a husband, father, and drummer for even longer. So let's look at today's agenda. Today we're going to be talking about an introduction to AWS SAM. We're going to get into AWS SAM templates, how to build reusable templates, and we're going to talk about the AWS SAM CLI. So let's get started. Meet SAM. Now, if you've heard the word SAM, you're not sure what it is, it's an acronym for the Serverless Application Model. And SAM comes in two parts to kind of help understand this. The first is the SAM templates. Now, SAM templates allow you to use shorthand syntax to express resources and event source mappings. It provides infrastructure as code for serverless applications. It's very specific to serverless, but you can do more than just serverless in SAM templates. The SAM CLI provides tooling for local development, debugging, build, packaging, and deployment for serverless applications. But also you can have non-serverless resources in there as well. So let's jump into SAM templates first. SAM templates. This is an idea of what a SAM template looks like. You can see here that I've got 20 lines of code. And in just these 20 lines, I'm going to create a Lambda function, an IAM role, an API gateway, and DynamoDB table. So what happens is these 20 lines of code then convert to infrastructure. And I can version this code because it's infrastructure as code. I can version this, I can change it, and I can push new updates. Now, if you've ever used CloudFormation, AWS SAM is actually built on top of CloudFormation. So as I said before, you can use any resources, standard CloudFormation resources within a SAM template, and then you can also use the serverless specific resources in the SAM template. And let me show you how that works. When you have a serverless resource, for instance, this one we have here, this is our get products function. This is a Lambda function. You'll notice that it's got a type of AWS serverless function. That's on line 5 here on the left side. You'll also notice on line 2, we have a transform. We're telling CloudFormation that when you receive this template, we need you to make a transform before you build it. So what will happen is we push this to AWS CloudFormation, and AWS CloudFormation will see that transform, and it'll take any non-serverless ones and pass them right over into the CloudFormation template. And it'll take the serverless resources, like this function we're using, and it'll convert it into a standard CloudFormation resource. So what happens here is these 20 lines of code now become 193 lines in CloudFormation. And I've cut a lot of these out so we can fit it, but you can see that the two resources we have on the left, which is the function and the product table, become multiple resources on the right. API gateways, roles, the table, permissions, different things like that. So both CloudFormation resources and SAM resources can be used in SAM. Now, there are 7 serverless specific resource types to look at, and you can see them here, and we'll go through each one to kind of explain it. The first one is the AWS serverless function. Now, this creates an AWS Lambda, and you can see in here that in this resource, we're creating the function, we're passing in properties like, hey, where's the code? Line 4 is the code URI. What's the handler? That's the function that we're going to invoke when we run this Lambda. What runtime is this? This one happens to be Node.js 12. And then we're going to pass some memory size, some timeouts, turn on tracing, that's X-ray. And then we get to line 11, says this is our policies. And policies are what are the permissions that this Lambda function will have when it's invoking. And in this example, we're doing DynamoDB read policy. And we're passing it a table name. Second thing we're passing is we have an environment where we can pass in variables, and I'm going to pass to the code the name of that table. So we know, hey, this is the access to the table that you need. And then finally, line 17 is the event. And this is the event that's going to trigger or invoke the Lambda function. Now there are 15 specific SAM supported event types that you can use, and you can see them listed here. including our brand new one, which is the MSK. Any of these can be set up to invoke a Lambda function within SAM. Now let's talk about policies for a minute. I showed how to set up that specific DynamoDB read. How this works is we have a list of over 70 AWS managed IAM policies that you can use in your Lambda function. And the best practice is to start here. Don't write your own policies. See if we've got one that applies already. If not, then you can start looking at using inline policies. And I've got a link here to the policies. So let me show you how that works. So in this particular example, I'm using the DynamoDB CRUD policy to show a little more. And this allows create, read, update, and delete from the Lambda function to the DynamoDB table. And I've cut out some of the permissions just so it would fit on the screen. And the second thing is, what resources are they going to apply? Now remember, I showed how we can pass in the table name, so it dynamically adds a table name and builds the limitations that says, hey, this Lambda can write to this DynamoDB table and this DynamoDB table only. And vice versa, only this Lambda can write to this DynamoDB table unless I apply this policy to another one. And so to remind you how they apply, on line 11 here, we have the policy, we show the DynamoDB read policy, this is back to our original one, and then we pass in a table name and it builds out the full policy for us. Now I want to talk about this last set of lines on line 14 and 15. These tell Lambda, or SAM specifically, how to build the Lambda function code. Now by default, it builds it according to the runtime that you pass in. So this is passed in Node.js 12, and it'll build that according to that. However, if I want to do some custom work against this, I can use a Makefile to do this. So I can set a metadata and use a build method and set Makefile, and then what'll happen is SAM will look for, in the same place that the code is supposed to be, it'll look for a Makefile, and it'll follow the instructions in that Makefile. All right, so let's jump to the next resource, which is the Serverless API. Now this builds a REST API, and obviously I'm not showing all the options available. There are a lot of options for throttling, caching, etc. But one thing I do want to call out is you can use OpenAPI to define your API here. So you see on line 5, I'm pointing to a swagger.yaml, or I can point to an OpenAPI.yaml, however you want to name it. And you can use standard OpenAPI to declare the resources or the paths of your API. So the next resource, much like the one we just talked about, is the HTTP API. And this is our V2 of REST API. It's also a REST API, but it is made to be faster, lower cost, and easier to use. So you can use SAM templates to create an HTTP API as well, and you can configure cores, throttling, different things like that. And here you can also use an OpenAPI to define the API structure. So the next one I want to look at is the simple table, which creates an Amazon DynamoDB. This isn't a new type of database. It's just a simple implementation of DynamoDB. And how it implements that is with a primary key of ID. It has dynamic capacity and AWS managed encryption. Now, if you want a little more control over that, that's okay. You can do that. In a simple table, you can add more parameters like, hey, what do I want to name it? What is my primary key? I don't want to use ID as my primary key. I can name it something else. I can handle my read and write capacities, tagging, things like that. And if this still is enough, then of course, as I've said before, you can use standard CloudFormation resources inside of SAM. So you could use an AWS DynamoDB table to get the full configuration options for a DynamoDB table. All right, the next one we have is the LayerVersion. And this actually creates a Lambda layer. And if you're not familiar with layers, layers allow you to share code across multiple Lambda functions. Rather than having to compile and package each set of libraries as such with each function, you can add a layer and that will be added to the function at creation or update. And you can control or manage those layers right inside of SAM template as well. I know that when I build it, I will have a separate template that handles all my different library layers. I may have a Node library or a Python library that are common libraries that I use, and then I can update those as needed, and I have the LayerVersion to add to my Lambda function. Now, just like a Lambda function, I can build layers in different ways. I can build them according to the language, and that'll be based on the structures. If I have like a node and then the node modules, things like that, it'll package that up. Or I can use a Makefile to do custom building as needed. All right, the next we have is an application, which allows you to use an external application, already kind of a pre-built service application, and pull that in. It can be in the service application repository, it can be an S3 bucket, something like that. So you can add those in. And the final one we have, which is the newest to our family, is the serverless state machine. And this allows you to manage a serverless state machine within a SAM template. And you can use an external template, definition URI, to use the .asl.json file. So with that, those are the 7 types of resources that you can use, serverless specific resources that can be used in SAM. But again, a reminder, you can use any standard CloudFormation like S3 or RDS or any number of things right there within a SAM template, and they'll work just fine. So let's talk about another section of a SAM template, and that's the AWS SAM Globals. Now, this section is all about being efficient when you do your infrastructure as code. So I'm going to do an example here. Let's say I have a function. This is a Lambda function called myCat function. And I'm passing the information. I've got the handler, the runtime, the code URL, the description, the memory size, and on and on and on and on, right? Okay, that's great. Now, I'm going to be honest, I'm more of a dog person, so I also wrote a dog function. So these are my 2 functions. I have a cat function and I have a dog function. And you'll notice here, there's a lot of overlap. Both of them have the same memory size, have the same timeout. They have the same, really the handler's the same, the runtime's the same. And so what's happening here is I'm taking a lot of lines of code that don't really need to happen. So here's where the SAM Globals comes into effect. With SAM Globals, I can actually move those into a global section. I can say for every function, I want the runtime to be node, I want the handler to be found in index.handler, timeout, so on and so forth. And that allows me to make my Lambda function code much smaller. Now, if, say, my dog function needs, a longer timeout or more memory, then I can override that. So if I add a memory size to the dog function itself, that will be the memory size that's taken. It will override the globals section. So bottom line, globals help you make your SAM templates even smaller by enabling you to reuse attributes throughout. Take advantage of the globals. Even if I have one Lambda, my standard template that I use the globals. You can also use globals for API, and there's some different areas that you can use that. So that covers most of the SAM template resources. Now I want to get into building reusable templates. Okay, so this is where the power of SAM really comes in, or the power of infrastructure as code, right? So let's look at this idea here. We have, if we're setting it up according to best practices, every environment is going to have its own account. So each of my developers are going to have their own account. I'm going to have an account for beta. I'm going to have an account for prod. And those are separated. Now, the reason I do that, one, so that I know that my developers aren't having to add parameters to identify who they are to their functions. That is their development environment. 2, in beta and prod, only the people that need to get to that. This is a security measure, right? Just inherent in the fact that accounts have security and logins, you have security, you secured your access to beta and prod. You don't have to build in a bunch of special roles. It's just by who can get into this, right? So the idea is I don't want to use different templates to build these different environments. So what does that mean? Well, that means that using the same template to build the same infrastructure ensures consistency across multiple environments. So if I have an application that I run from developer, it goes through beta, it goes to prod, you may have more. You may have, staging, alpha, gamma, delta, whatever you want to call it. But the same template can push through those. However, you may use different parameters. You may say, hey, when I'm in developer, I have a developer database string. When I'm in beta, it's a different one. When I'm in prod, it's even a different one. So I need a way to isolate these. Well, there's a couple of ways you can do that. Let me walk you through this. The first is just in parameters itself. So parameters are part of the SAM template that I can build out, and I can say, hey, you have to pass me, in this example I'm showing you have to give me a domain name. a zone ID, and a cert ARN. And this particular template was for building out custom domains on an API gateway, right? Or you may say, also, I'm going to pass in parameters like a DB engine, something like that. And there's a couple of things you can do. First of all, understanding the types of them. The types are, you can pass in a string, a number, a list of numbers, a comma delimited list, and then you can pass in AWS specific parameter types. And these are going to be resource types like a VPC ID or a zone ID, something like that. And then you can pass in from SSM, from AWS SSM or AWS Secrets Manager parameter types. Right? And so here's an example of this in the bottom box here for the DB engine. I'm storing the DB engine inside of SSM. So I can tell SAM that, hey, the value I want is at AWS SSM parameter, and then request the value. Okay, so and then it's going to expect a string for that value. And then when I deploy this application, I can pass that value in, or I can just let it use the default. So this is a little trick for saying, hey, I always want you to grab the SSM key located at myapp/DB engine. That's the default unless I override it. And then what'll happen is, instead of you having to pass the actual value in, you just pass the location, and SAM will go to SSM parameter store and grab that value and import it into the SAM template or to the application. So a helpful way to do that, rather than passing values in, you can store it in the parameter store or in a secrets manager. And I'll kind of show how that works in just a second. I mean, if you think about that, that means since SSM and secrets manager are isolated to each account, that means that the developer, he'll get one value, beta will get another value, and production will get another value. And we don't have to pass those in at deployment. We just say, hey, here's where they're located. And here's what that looks like when we're doing it inside the template. So a couple examples. So on line 9 here, I'm referencing that DB engine. So I can just say, hey, whatever you passed in is the DB engine, or whatever was set as the parameter. But I can also use inline resolvers to secrets manager or SSM. And this just gives an idea on how to do that. And if this doesn't make a lot of sense, we only have an hour, and this is 5 hours of stuff to explain on that. But don't worry. There's actually an episode I did called Storing Secrets, and it's on my Sessions with Sam series. And I would encourage you to follow this link, grab that QR code, and I list out all the abilities that you can do with SSM, with the Secrets Manager, and how to pull those into SAM templates. So I hope that helps. All right, so the next thing is pseudo parameters. A lot of times when you build an ARN, or you pass in data, you have to know, like, hey, what's the account number I'm working under? Because let's say I'm reusing this template across 1,000 accounts, and I need to know what account I'm in. Well, I could have them pass that in, but that's really kind of a pain. Instead, I can use a pseudo parameter, which is, as you see here, it's identified the AWS and then colon, and then I can get an account ID. I can get a region. I can get the stack ID or the stack name, the partition, or no value. No value is kind of interesting, where I can actually pass in a null value, which is kind of tough in JSON sometimes. So I can say, hey, based on some conditions, either set it to this value or no value, meaning don't set this parameter. The second part of that is intrinsic functions. Now, if you've used CloudFormation, you've seen these pseudo parameters and intrinsic functions, and they also work within SAM. Now, I'm showing the long form here. You can also do the short form. Now let's put this together and kind of give you an idea of how these work. And this is just one of many different ways of using this, but just get kind of an idea. In this first example on the top, I output an endpoint for Amazon API Gateway. So an API Gateway endpoint is the HTTP API ID, and then execute API, and then you have to have the region, and then Amazon AWS.com. So I can say, I can do a sub function, so that's one of my intrinsic functions. I can do a sub and say, everywhere you see $serverless HTTP API, ref that serverless HTTP API to put that in, or refer to that value and dynamically load it. So you can see here where that gets really powerful in the ability to reuse templates accordingly. The second way of doing this is in create conditions. And so you can see here, back to my example using the domain name and the zone ID and the cert ARN, different things like that. So with those values that are passed in, I'm going to create some conditions. So what I'm going to say is if I've set a default to none for both zone ID and cert arm. So I'm going to say if that equals none, then we need to create the zone. That means that they don't already have a zone, so we need to create that. And the same with the certification. So again, this is used for creating custom domains on top of HTTP API or REST API. And then down within the template, I can use those conditions. One example is if I'm going to generate a zone, I'm going to add a condition. I'm going to say, hey, if create zone is true, then generate a zone for me. And that's what happens here. Same with generate cert. If the condition of create cert is true, then I'm going to generate a certification. And the last one here puts that all together on HTTP API gateway. Here's what I'm going to do. I'm going to say, when I'm looking for the certificate ARN that I need, I'm going to say, if create cert is true, then use the generated cert. This is line 6 in the bottom right box. If it's not true, then use the cert ARN that's passed in. So you see, again, you have a lot of dynamic options in making templates reusable. So I encourage you to spend some time looking at intrinsic functions, looking at pseudo parameters, looking at parameters being passed in, and how parameterized can you make your templates. All right. So we've covered the AWS SAM templates part of this. Let's jump into the AWS SAM CLI. All right, so the SAM CLI is the command line interface. And this is something you install locally onto your system that you can use. The CLI is a tool for local development, as we talked about. It supports API gateway proxy style. That's REST API only right now. That doesn't mean you can't test HTTP API, but the proxy style Start API, and we'll get into it in just a minute, is for REST API only. You can get a response object and function logs available. You can also connect directly to CloudWatch to get logs from live in production Lambda functions. It uses an open source Docker Lambda image that's actually managed by AWS now to mimic Lambda's execution environment. And you can tell, as I was just mentioning, you can tell logs from CloudWatch logs for Lambda functions in production. It can help you build in native dependencies. And here's a link to it, aws.amazon.com serverless SAM. And that, again, that's the overall link to SAM, but it'll link to SAM CLI as well. So the first command we're going to look at is SAM init. And SAM init creates a new serverless application. And it allows you to choose the runtime you're going to use, choose the dependency manager. For instance, with Java, you can use Maven or Gradle. That allows you to set the output directory, where do you want the application to be, the name of the application, and the location of maybe a custom template. So when I'm doing a SAM init or initialize, I can say use an AWS managed template, which is like a Hello World or a DynamoDB backed website, or I can create my own template and use that. So if I have hey, I always build my web applications starting with this and a specific structure, then I can create a template out of that and initialize my new applications with SAM using my custom template. So what does that look like? Well, you can see here where we do the SAM init, it asks us which templates we want to do. If it says what runtime do you want to use, and then we name the application and it'll actually pull it down. This pulls down all the templates for you and updates those or refreshes those. And then you can choose which one. I chose the Hello World in this. And then it generates out the application and tells you, hey, here's where it is and here's how you can work with it. All right, so that's SAM init. Now, when you're done, it creates a serverless application based on your input. And so this is how the file is structured. You can see I've got the app, I've got a README with instructions on it. I've got the events, and these events are for testing. So if I want to do an invoke, which we'll talk about in a minute, then I can use these events to test with. And then the actual Hello World Lambda function code is in the app.js, as well as the package manager for Node, that's package.json. And then finally, the last one is the template.yaml, and that's that. We've been talking about SAM templates up to now. That's that manifest file or that infrastructure as code file that says, here's what my application should look like. All right, so the next one we're going to talk about is SAM build. Now, SAM build generates deployment artifacts targeting the Lambda's execution environment, right? When you use a SAM build, it can build the code right there. You can also, and it'll use your local machine, or you can tell it to use a container to compile for native dependencies on Lambda execution environments. Let me explain what that means. That's kind of a mouthful. So All Lambda functions run on Amazon Linux or Amazon Linux 2. And most of the new runtimes are being migrated over to Amazon Linux 2. So if I have some compilation that needs to happen that's specific to the architecture I'm targeting, then I need to have that dependency, right? I need to have that architecture to build on. So I can pass a flag in SAM build that says use container, and it'll use a container to build those using the proper architecture for the execution environments, right? All right, so it then utilizes native build tools like .NET, Go, or Maven. So if you're doing .NET Core on a Lambda function, you can use the .NET Core, the .NET utility, and SAM will tie right into it. It allows for file omission, so you don't have to push all your tests up with there. You can say, hey, omit these when I'm actually going to production. And then, as I said before, you can use Makefile for custom builds. So let's look at what a SAM build looks like. So again, I'm using a simple node here, but this works for all the runtimes. And I can say SAM build, and it's actually going to go through, and it's going to walk through. Now, I only have one Lambda function here, but if I had 10, it would walk through each one and package all the resources and all the dependencies needed individually. So let's talk about that for a second. Let's say I have hello world function 1 and hello world function 2, and they both rely on the AWS SDK. Let's say we're using, I don't know, any number of dependencies that you have or want. Well, it's going to package those individually with each function. So hello world 1 is going to have that packaged up. Hello world function 2 is going to have that packaged up. So you kind of start to see where layers becomes very handy. Okay, so if I use a layer and just attach that layer to each of these functions, then I don't have to upload those dependencies every time. Instead, they'll be pulled in when the Lambda service will do it when I'm creating or updating a function. All right, so finally it says, okay, everything's out. The commands you can use next, or you can use a SAM local invoke, which we'll get to in a moment, or you can use SAM deploy guided to actually deploy the application. So let's look at a SAM build with Makefile option. Now this is one that I did, and you can get a link to it here. It's a Swift one. If you're an iOS developer and you want to use Swift in your Lambda functions, you can absolutely do that, right? And it's dependent on the Lambda Swift integration that's been built here. And so what this does is this actually, through this Makefile, I set some variable names, I create the directories needed, and then I compile using the Amazon Linux Docker image with Swift on it. So there's a specific Docker image that I need to do that I created. And then when that's all done, I copy the dependencies to a staging area. I copy and rename the binary to a staging area. I collect all that together and I copy it to the artifacts directory. And in SAM build, the artifacts directory is that .aws SAM folder. And then there's a folder for each of the functions being built under there. So that's just an example of a Makefile and how I would use that to do custom builds. And man, these can look different for any number of ways you approach that. So the next thing we're going to talk about is SAM package. SAM package packages a SAM application. I mean, it's right there in the name, right? So it packages a SAM application and gets it already. And what does that mean? Well, so it's going to take, and wherever you're pointing to, it's going to say, okay, so if I've done a SAM build, it's going to grab from a SAM build. If I don't build and I'm just doing raw code, then it's going to point to those. Wherever the template points to, it's going to zip all that up and upload the artifacts to an S3 bucket. Now, this is now built into the SAM deploy process. And if you're just doing local development, most likely you won't use this function. However, if you're doing a CI/CD and you've got one that's dependent on package, we left it in there, it's still available. You can package everything up without deploying. And this is probably how you want to approach it when you're doing a CI/CD anyway, so that you're not deploying from command line. Instead, you can use CloudFormation directly to deploy it based on the artifacts that SAM package puts out. So here's what that looks like. SAM package, I pass the bucket that I'm going to use. I pass the template that I wanted to output as. So I have an input template that's going to be template.yaml. That's default. And I want you to output a new one called out.yaml. And it's going to loads everything and then renames where the code resides in the out.yaml. You can see here that it's doing the uploading. And it tells you how to deploy this if you want using the CLI. But you can, if you're using code deploy, code pipeline, you can then pass these artifacts to CloudFormation to deploy. All right, so let's talk about SAM deploy. So it deploys or updates serverless applications on AWS Cloud. It deploys and manages an S3 bucket for deployment artifacts. No longer do you have to create a bucket and manage that. SAM deploy is going to deploy that and manage that for you. And it saves deploy options to a config file. All right, so earlier when we talked about parameters, if I have a bunch of parameters I'm asking for, when I do a SAM deploy guided, as you can see here, it's going to ask me to fill in these parameters and then save those. Now, it will not save things like if I do a no echo, I can pass a no echo parameter on, or no echo setting on a parameter, then it won't save those. So you do have the option to not save them. But simple things like, hey, what's the name of my stack? What region am I building in? What's the parameter deploy environment dev? So I can override that so you can set defaults. So it'll save those into a config toml file. When I'm using SAM deploy guided, it asks me all the questions, and you'll even get some warnings in there. If you've got a Lambda function that has no security wrapped around it, it'll call it out. Say, hey, this doesn't have an authorization. Are you okay with that? You say yes, you move on, and it'll save that answer, and you don't have to do it the next time. Once it's done, then it's going to go through this. Now here's how deploy works, and it's using CloudFormation. So first thing, we're going to say deploy guided. We're going to fill it all out. It's going to say I'm deploying it with these values. Here's how I'm going to do it. Then it uploads. You might recognize this. It came from package. Then it's going to upload those, and then it's going to wait for a change set to be created. And you'll get this feedback in your console. So what happens then is it's going to go through and it's going to create a change set. And it's going to say, this is what I'm going to do. I'm going to add these. I'm going to delete these. I'm going to modify this. However, now this is a brand new one, so it's going to add them all. Now, in your options, when you do SAM deploy guided, you can say, hey, once I show you the change set, do you want me to stop and wait for your approval, or do you want me to just cruise on through, right? So that's up to you. If you like to see that, look at that, you can certainly do that. So the next thing it's going to do, once the change set is there and you've either auto-approved it by saying, no, I don't need to approve it, or you've said, yes, I approve, then SAM deploy is going to execute a change set using CloudFormation. And you'll get feedback, creation in progress, creation beginning, creation complete, all those kinds of things. Then when everything is said and done, you'll move to the output. And if you've set some outputs, it'll tell you, hey, here's those values you wanted. Here's the role for whatever you're building. Here's the API endpoint. However, you can set up your outputs however you want to do that. And we didn't talk a lot about outputs. Outputs are part of the template section where you can go in and say, I want it to be named this, and I want it to have this description and the value. And you build that just like we showed on how to use the intrinsic functions, the pseudo parameters, and parameters passed in, and referencing the logical names to grab the data that you want. When all is said and done, when you go into CloudFormation, you look under resources, you can see these under there as well. And I've built one Lambda function, one API gateway. All right, so that's SAM deploy. So let's look at SAM local. And SAM local has several commands that work with it. So we're going to talk through those real quick. But there's a generate event, start API, start Lambda, invoke Lambda. All right, so let's talk about SAM local generate event. I get questions a lot on what does an event look like. When S3 triggers a Lambda function, what does that event look like? What data is included? When DynamoDB streams trigger a Lambda function, what does that look like? Because they're not always the same because it's different structures. Well, the quickest way to do that is to do a SAM local generate event. And of course, you can do SAM local generate event help, and it'll tell you exactly what you need to do. But this is an example of SAM local generate event S3 put. So I'm saying I want an S3 event with a put event. And this is what it looks like. Now there's more to it. Again, I'm abbreviating this for display, but you get the idea that it gives out the data. And so what I'll do is I'll do a SAM local generate event, S3 put greater than sign event-s3.json. So then I've got that event saved. These events are very helpful when we're running the SAM local invoke, start API, different things like that. All right, so let's look at SAM local start API. This is probably one of the more common ones you'll use. SAM local start API will mount and use a proxy style API gateway to invoke your Lambda functions. right? And it'll tell you, okay, I'm mounting it here at 127.0.0.1:3000, and I at /hello, and it is a get, right? So then what I can do is I can curl that, or if I'm using a browser or however, I can hit that endpoint, and I'll get feedback from the server that's running, and it'll tell me. So if I have console logs in there, those will get output. And so you have a lot of different flexibility here to see what's going on. So just having a couple terminal windows up, one to kind of watch where things are going. So here's how I'll do it. I'll get my service all ready, and if I'm running a local client against it, I'll point it at this, and then I can just pound away and test, and I'll get answers here. One nice thing about this is, unless you change the template file, you don't have to restart this every time you change the code on your backend. So if I have 3 Lambda functions that are handling maybe create, read, and delete or something, if I make a change to one of those, the next invocation will pick up that change. Now, here's some helpful options for SAM Local Start API. You can pass in environment variables. So with your Lambda functions, sometimes we pass in Lambda variables. In fact, that's a best practice. If I'm going to access a table, a DynamoDB table, I should pass the name of that table in as an environment variable. That way I dynamically build that Lambda function, and it keeps my template nice and reusable. However, local doesn't know about those. So I can build an environment variables template to show how to do that, right? I could pass a debug port and path when I want to attach a debugger. I can output a log file. If I'm working with like a Docker network, I can also set a static directory where I'm looking for static resources. So that's SAM Local Start API. And this, in a nutshell, this emulates an API Gateway REST API, right? So let's look at Start Lambda. This is SAM Local Start Lambda. Now this one you probably won't use as much unless you're building a service that is calling Lambda directly against the Lambda API. So on AWS, everything that invokes a Lambda function does it through the Lambda Service API, right? So you can actually, using the AWS CLI, you can invoke a Lambda function via that same API. So if you're building something that's going to invoke that way, and you want to see how it's going to work, you can use the Start Lambda. And just like Start API, it's going to come up, it's going to stay up until you kill it, until you do a Control-C. And then as you invoke against it, and here's a command, the AWS Lambda invoke, and you pass function name, endpoint URL is the local one. You're not going to verify SSL, and then you can output the text you want. So you may or may not use this as much, but it's very handy when you're building those kinds of services. And much like with the Start API, there's a lot of different options you can pass in to work with these. So this is one you'll use a lot, okay? If you're testing locally with SAM API, I think this is one of the most commonly used ones. This is the SAM Local Invoke Lambda. And this invokes the Lambda directly. It's not as if going through an API gateway, but it's a good way to just run and test it. Right? So your output here, if this were going through Start API, we wouldn't see the status code, we wouldn't see body, we would just see what was in the body. That's about the only difference here, okay? So when I do SAM Local Invoke Lambda, it's going to invoke the Lambda and then go away. So again, it says this through the Lambda API, but it's hitting it directly. This is a good way to test HTTP API. You can do an HTTP API event, right? So you can say, what does that look like? And then I can pass in an event, and I'll talk about that in a second, and then it'll respond and I can look at what that looks like. All right, so here's some helpful options for SAM Local Invoke. Again, environment variables, the event itself, so you pass in the function name, then the event itself. So remember, we looked at what does an event look like. I'm going to do SAM Local Generate Event. To get that event, I'm going to save it out. Here, I can literally just say --event, and then I can pass the file with that event name, and it'll use that as if it's the event passed into the Lambda function. And then obviously debugging, log file, static directory, and Docker network, just like the other services. So hopefully that makes sense on the SAM Local Invoke and the differences between those. All right. Now, one thing to understand is that SAM Local is build aware. Okay. So when we talked about building, we talked about this artifacts directory. And so what happens is when I do SAM build, let's say I'm using .NET or I'm using Java, something that I have to build every time I make a change, right? So I'm going to build it, and you're going to get this artifacts directory in AWS SAM build. And then what we need to do is when I run SAM local, it's going to invoke against that build folder under .aws SAM. That's the template it's going to use. So here's where that can be kind of confusing. I know that, like, especially as a node developer, where I don't have to compile, I will often make edits in the actual folder called Hello World. And I'll make those edits and then I'll save it. And then I can't for the life of me figure out why they haven't taken effect. Right? It's like, well, none of my changes are showing. And I, 7 to 12 hours later, I realize, I didn't build, or I still have that build folder sitting out there. So there's two ways you can handle that. One, delete the .aws SAM folder. That's okay. It'll be regenerated on the next build. You're not going to lose anything there. Okay. And if you do, don't store anything that you need in there. Okay. So if you're using custom builds with the Makefile, don't store things that you can lose. All right. So then what happens is if I delete that, then I run SAM local invoke, then it's going to look at the main template. So the template under .aws/SAM always takes precedence. Just be aware of that. All right, hopefully that just saved you hours that I had to give up. I give them to you. All right, so let's look at SAM logs. SAM logs is a great utility for connecting to CloudWatch logs in AWS Cloud with live production, Lambda functions or testing functions. So this is really handy if I'm doing some asynchronous work in the cloud and I need to make sure it's working. So for example, let's say I'm pushing stuff onto EventBridge. I'm using the brand new HTTP API direct integration with EventBridge, and I'm pushing stuff onto EventBridge, and then I've got some rules that are triggering a Lambda function. So this Lambda function is being invoked, but I want to know, is it working? Is it doing as it should? So I can actually connect to the logs for that Lambda function, and I can do a --tail. So let's look at some of these helpful options here. I can do a tail on that, or -t or --tail, and my terminal will sit there and it'll continually fetch logs. So I can push stuff into the EventBridge and then I can see them come out in my logs. I don't have to go to CloudWatch to see those. So it lines right up. It's very helpful. I love this tool. I use it all the time. It's very helpful. All right, so there are some things you can do with it. You can filter. You can use simple keywords or CloudWatch supported patterns. You can use a start time. You can use an end time. You can use a tail. So you can say, hey, I want everything after yesterday at 2. And you can literally just say yesterday. I want everything after yesterday. I want everything before, 2 days ago. Or then, like I said, we can use the tail to continuously fetch logs. Very helpful tool. Hope that helps out. All right, so let's talk about debugging locally with SAM CLI in VSCode. All right, so with this, you're able to, in VSCode, you can create a debug configuration. Right, so you create a debug configuration, then you can add breakpoints, and then when you invoke the Lambda using start API, start Lambda, or invoke Lambda, you can attach a debugger. So it allows you to do breakpoints and walk through there. And here's a link here to kind of show in greater depth than we can do in the short time I've got here to kind of help you understand how this works. All right, now let me show you real quick kind of video. So you can see here, I've got my code in there. I'm going to add a breakpoint. Right. Then what I'm going to do is I'm going to make sure that I'm going to run my SAM local invoke, and you can see here I'm passing in an event, I'm passing in a debug port, and then I'm telling it which function I want to run. So it's actually going to go out, it fetches the right Lambda, and then we're going to look here, and you can see I've got my debug configuration in place. With that, then I can go ahead and attach the debugger. And I can step through and you can see that I've got the values that are being passed in easily attached, and I can use obviously the call stack and different things like that. So very helpful when you're working with that. All right, so we've covered a lot of data in this session, and I openly admit I probably went pretty fast, but I wanted to get you to so much more that I could tell you about SAM. And so I'm going to give you some resources when you step away from here. I'm leaving these links up here for a little while. You can grab the QR code. Hopefully those work if they're too small, too big, but I've also put the links. And here's what they are. The first one is the AWS SAM on the AWS website. So go here, it's a great starting place. We'll talk about the templates, we'll talk about the CLI, getting started, installing, documentation on the different resources, much more in depth than I was able to go to on here. A second thing I would point you to is the Sessions with Sam playlist. Every Thursday, I host a show called Sessions with Sam where I devote a half hour just to Sessions with Sam. We talk about specific services, we talk about best practices, all kinds of things, and it's all saved in a playlist. We're in 2 seasons now. So there's a lot of information, things like HTTP API, custom domains, custom builds, EventBridge. I could go on and name more. The third thing is the Sessions with SAM repository. And this is also, there's a short link to that. And this is the code behind the show. So not only do you get to watch a show and understand, hey, here's how I did it, but you can also grab the examples from here. And there's also some code in there that don't have a show, but I felt would be very helpful for people. So I throw up examples on how to do SAM templates. With that, I'm going to leave you. Again, my name is Eric Johnson. You can find me on EDJ Geek on Twitter. Glad to answer any questions. We're going to try to answer as many questions as we can right now near the end. But reach out to me if you don't get your question answered. I'll do my best to help. Thank you so much. Have a great day.